So, hello everyone. I think remember in the last session we did window, right? Window air conditioner. In today's session, let me continue with the split. Okay, split air conditioner. In that split, you'll find different types. So we'll talk about split. In that, we'll also discuss the different types of split. And next, we have ductable split, package, etc. Okay, so let me continue with the split air conditioning system. So the name will give you some idea. Okay. So see, if you compare window with the split, in a split air conditioning system, the four components, what we discuss, the four major components, what we discuss in window is going to divide into two different units in a split air conditioning system. So we'll discuss all in detail. So the first point is why the need of splitting that components into two units. Because you see, we are getting the cooling from the window. So the first point is why the need of splitting that four components into two units. The major reason why the need of split. But before this, let me share the screen. Here you can find an image, just a overview initially. Then we'll discuss in detail. In this image, you can find out this is indoor unit and this is CU condensing unit or outdoor unit. Okay. So in outdoor unit, you'll find compressor and condenser and even expansion device also. And indoor unit, you'll find evaporator. Okay, I'll give you the detailed information about the components. At this level, just I'm discussing in general to get the idea why the need of splitting this why the need of splitting these components into two units. Okay, so this is a indoor unit and this is a outdoor unit. And in general, this indoor unit we used to call FCU, nothing but fan coil unit. And this fan coil unit is common for split system, for VRF system, even for chill water system. Okay, so we have a separate topic of FCU after completing this package. Before dealing with the chill water system, we'll discuss the difference between FCU and AHU. Okay, so remember this unit we can call as FCU, fan coil unit, or in general indoor unit. So the major reason why the need of splitting this components into two units is to reduce the noise. Okay, I think remember in the last session we discussed about the window, and in window, under the disadvantage of window, we discuss noisy type of machine, right? Because the compressor is close to the conditioned space now. So whenever you use that window AC, you'll get the noise from the compressor. Okay, and noise also one parameter for maintaining the air conditioning now. So if you split this components into two units, one can reduce the noise because in outdoor unit you'll find the compressor, okay, and the noise and the vibration from the compressor now, so that we are going to separate in outdoor unit which we are placing outside the space, outside the building. So one can reduce the noise. This is the major reason. Apart from this, we have some advantages and some disadvantages also for this, but the major advantage of split is one can reduce the noise compared with the window. Okay.
For window, we can put the like the partition one, like in between there is a room, so we can put that window. Window AC in that, but in between room. But this split can be put, right? This is an advantage.
No, you see, we have a list of advantages. At this level, what I discuss is only the major point. Okay, we have a lot of things to discuss. Don't do the conclusion at this level. So here you see split AC, also known as split system or the split AC in actual practice. And this also comes under unitary system. Window, split, both comes under unitary type. Why I'm talking about this unitary? Because you see, if you talk about the ductable package, etc., that comes under central air conditioning system. In that sense, these two units we can consider as a unitary. Unitary means the unit wise as per the zone requirement. And here I request to make a note of this point. Please make a note. Zone refers to thermostat.
Which one?
Zone refers to thermostat. We'll discuss in detail. I'll give you the quick idea for the zone. For example, because repeatedly I'll use this term zone, that's the reason you must aware of this. For example, consider a floor with say multiple rooms. For example, total say 6 rooms. 1, 2, 3, 4, 5, 6. Okay. So in general, we used to call room. Technically, for mechanical or electrical, we used to call spaces. Okay, so these are all total 6 spaces. And in each space, I'm going to use a split AC. Suppose split AC 1, 2, 3, like so on, 4, 5, 6. And for this, we have a separate outdoor for each unit. So you see, in this case, number of space is 6. And in each space, I'm using a separate individual split system. So zone also 6. Because one space, one unit means one control, means one thermostat on and off individually can operate all these rooms. In case if I use a central AC and if I use a package or a AHU, and if I connect all this with the one unit, I'll show you how exactly. Just this level, focus on the zone. So just by some means, if I cover all this space with a one unit, in that case, number of space is going to be 6, but zone is going to be 1. So remember, zone refers to thermostat, how you're going to control the spaces. If all the space is going to control with one unit, means one thermostat. So number of spaces 6, but zone is going to 1 in this case. It can be 10 space, 10, 20 space, whatever as per the space, as per the project requirement. So I think got the idea of what is a zone and space online.
Yes.
We'll discuss with more detail. Don't worry. At this level, just so now you see what are the different types of split. So the major point, the split consists of what? An indoor and an outdoor. Compare with the window. And remember, if you talk about the 4 major components, what we discuss in vapor compression cycle, the same we use in window. Na? In split also, you'll find the same components. I'm talking about the major components. So if you talk about the 4 major components, compressor, condenser, and expansion, you'll find in outdoor. And in the indoor, you'll find evaporator. If you talk about the main components. In the latest models, if you talk about old models, expansion you'll find in the indoor unit. Okay, why now in market they are using the expansion in the outdoor unit? There is a reason we'll discuss. Let me just complete this theory part first. So now if you talk about the different types in split, you will find n number of types, but most commonly in actual practice, you can find high wall. You see on screen, this is high wall. And this high wall cassette or this tower is based on the FCU. You see, as a cell, in general, this we can call as FCU, fan coil unit, and coil refers to the cooling coil. So this high wall cassette and the floor stand or tower is based on the FCU. The outdoor is going to be same for all the 3 types. Means the concept is same, but the type of indoor is going to be different. Nothing but FCU according to the interior requirement or the site condition or the clearance or interior requirement. So if you know the mechanism of high wall, the same principle is for cassette as well as for tower. I'll give you all this detail, don't worry. So there are 3 types most commonly in actual practice. High wall, you can find on screen. Next is a cassette. Let me just show you the preview. This is a cassette. I'll show you detail with this small video clip also. This is, and you see this is again connected to the outdoor, and this is ceiling suspended. So high wall is going to install on the wall above 6 feet as per standard, and the ceiling mounted is a cassette, and this tower or floor mounted. Quickly, let me show you the preview. We'll discuss in detail. Tower is like a vertical unit. You can find on the screen. You see, this is called tower or a floor stand. Some used to call freestand also, but I'll not recommend to use the term freestand because once you install, you cannot move this like air cooler. Because again, this also connect to the outdoor unit. Apart from this, you may find the ceiling suspended type, or else you'll find a floor mounted FCU, or you'll find one-way cassette, two-way cassette. Different models are available in market, but most commonly in split, you'll find high wall, cassette, and the freestand. So first, let me complete this high wall. So you can find the first type in this is a high wall. And why we are calling high wall? Because we are going to install on the wall with at least above 6 feet height from FFL. FFL, if you don't know, please make a note. It's a finished floor level. In short, we used to call FFL. We'll discuss about this terminology at the time of building survey. So final finished level of floor is called FFL. From FFL, not less than 6 feet, above 6 feet only, because up to 6 feet we are considering as a occupied zone. What is occupied zone? You'll find the time of topic called air distribution. So next, what are the components in indoor? You see in this high wall, this is called FCU. So first we'll talk about the components inside this, then the components of this outdoor unit. Okay, so I've given the list here. Let me read this first. Everyone aware of this evaporative coil? We'll discuss that at the time of evaporative cycle. I'll show you the fins and the coil in a small video clip, which is common for condenser as well as for evaporator. So in the indoor unit, you'll find evaporative coil. You'll find the blower, cross flow blower. Blower is a type of fan. I'll show you in the video. Give me a minute. You'll find the air filter to clean the air at the time of suction. You'll find the blower motor, which is used to run that blower, means the fan. You'll find the control panel, which is used to operate the remote control and other function like the current and all, the power. Next, drain tray at the bottom, which is used to collect the condensed water. On evaporative coil, you'll find the condensation of water. No? So at the bottom, you'll find a passage which is used to collect the water. We used to call drain tray. Next, supply and return outlet. Don't worry, just let me read this. I'll show you all this in the picture as well as in the video. Next, air deflection motor. A motor inside a small motor which is used to operate the swing blade at the outlet. And you'll find the swinging blade, which is connected to a small motor. Remote control, everyone know this. And suction and liquid line outlet, okay, which will connect to the with the copper pipe, and that copper pipe we are going to connect to the outdoor. And why we are calling suction liquid line, that also we'll discuss. So these are the components for indoor in the high wall. Similar components you'll find in other units also. The shape and the position may vary, but the component is going to be same. Next, if you talk about outdoor unit, as we discussed at the beginning of the session, compressor. You'll find the compressor, no doubt. Condenser, which is used to reject the heat. So that must be outside in the outdoor unit only. No? Expansion device. In present market split system, you'll find this expansion device in outdoor only. In some models or in older models, you'll find this in indoor. Now the point is, if you place this expansion valve in the indoor, it's after expansion, the pressure drop, na? After expansion only, we have this low side. Then why we are using the expansion device in outdoor? You see, the concept of split is for what? To reduce the noise na, compared with the window. So if you use this expansion device in indoor unit, what will happen? You'll find the hissing sound, because at the time of expansion, the refrigerant is going to be supplied with a very narrow cross section to the wide cross section area. Na? So you'll find the hissing sound. So again, to reduce that hissing sound in present market, you'll find this expansion device also in the outdoor unit. Okay, in old models, you may find in the indoor also, or in some models, some makes, they are still adding in the indoor. But if you talk about high class like Daikin, in Daikin, you'll find the high class models, or in many makes, standard makes, you'll find in the outdoor only. Next, a separate fan motor, which is used to run an axial fan, which is used to cool the condenser. It means for condenser fan. Next, electrical components, again for power supply and providing the power to all these components. Again, liquid and suction line, which is common in both the units because interconnectivity of the pipes. You see, drain outlet is going to be a part of indoor. Next, let me confirm all these components. But before this, I'm going to play a small video clip. You'll get the idea about this coils. It can be a cooling coil or it can be a condenser. In both, you'll find the copper tubes and the fins. Okay, so I'm going to play the video. First, let me confirm these coils. Then in other video, I'll confirm all the other components.
One essential component in air conditioners must be the heat exchanger in its dual application as a
Can you see this copper tubes? And you see this copper tubes with a bunch of fins. You see this thin plates is called fins. And as a mechanical, you know the purpose of fins, right? This fins is used to increase the rate of heat transfer by increasing this surface, right?
Surface area.
So this is common for any heat exchanger. Okay, or this condenser or evaporator in general is a heat exchanger only. No? This tubes you'll find with the copper and fins with the aluminum. This is a default configuration in actual practice. In some models, you will find copper tubes, copper fins for the models, which is going to use in high humid areas. Or apart from this in market, you'll find copper tube, blue fins, or some additional coated fins, which is used to increase the life of this. Because this, if you talk about this heat exchanger, the same heat exchanger we can use as a condenser in outdoor unit. So if the outdoor unit is placed in the humid areas, if it is aluminum, the life is going to be less. So in that case, even the fins also you'll find is made up of copper or with the additional coating. That depends as per the model. But if for interview point of view, the default configuration is copper tube aluminum fins.
Denser as well as evaporator. Changing from smooth bore copper tubes to internally enhanced inner groove tubes enable a move towards higher efficiency heat exchangers. The process of coil making includes the use of...
You see this process called drawing process, and remember the copper tube is welded and seamless. The copper tube is a seamless pipe, not welded pipe.
Hairpin tube cutting and bending machines, which draws the tubes from the copper reels, cuts them to the required length and bends them 180 degrees. Alongside is the fin pressing, where the punching of holes, corrugating of the surface and cutting to the required dimension takes place. Fins are then collected, end plates attached and hairpin tubes inserted, thus forming the heat.
Here you see, you can consider this heat exchanger as a 3-coil heat exchanger. You see, 1 row, second and third. So it's a 3-coil or 3-row heat exchanger. You may find 1 row, 2 row, 3 row, 4 row, depend as per the capacity or as per the model.
Exchanger coils. Coils are then moved to the mechanical tube expander, where mandrels are inserted to each tube, which mechanically bond the hairpin tube to the aluminium fins. The return bend machine fabricates copper return bends or elbows from copper reels, and then the brazing rings are inserted mechanically. One final step completes the circuiting loop for the successful flowing of refrigerant through the heat exchanger coils. Loaded onto the brazing conveyor,
you see here we'll apply heat, and this process is called brazing. So to complete the circuit,
coils are fitted with elbows and brazing rings. After pressurization, coils move over to the automatic brazing furnace for leak-free connections. Connecting the various air conditioning components requires accurately bent copper tubes. Utilizing CNC three-dimensional copper tube bending machines that conform to the hundreds of various coil connections permits error and defect-free production of volume and quality.
Yeah, so you see the heat exchanger, what you observe in the video, is common for not only for split, even for ductile split or for package or even for VRF, you'll find this heat exchanger, and the procedure is going to be same.